Let's do some explicit calculations of finding the sums of points on an elliptic curve. The curve we're going to look at is y squared equals x cubed plus x squared minus 720x plus 5184. If you graph this, and I encourage you to graph it on Desmos, you get a graph that looks something like this. The point P, negative 24, negative 96, is a point on the curve, as is 8, 0. And of course, you can check that by taking these points, x and y, and checking that each one of these satisfies this equation. Now, in pictures, we can see that the sum of P and Q can be found this way. You take the line through P and Q, find out where it crosses the curve. That gives you the point P star Q, and then you reflect that across the x-axis to get the sum P plus Q. So let's go through the explicit algebra to find out what the coordinates of P plus Q are. So first of all, let's find the slope of this line. The slope will be y sub 2 minus y sub 1, 0 plus 96, over x sub 2 minus x sub 1, which is 8 minus negative 24. And 96 over 32 is 3. And then we can find the equation for the line using the point slope formula. Now, since the line goes through both points, I can use either one of these. I'm going to use Q since it has simpler coordinates. So y minus 0 is 3 times x minus 8, which is 3x minus 24. So y equals 3x minus 24 is the equation for this line. Now, if you like to check your work as you go along, then you can take each of these points and make sure that it satisfies the equation for the line. Now, this line intersects the curve 3 different places. The way we can find where this line crosses this curve is to substitute 3x minus 24 in for y, and then solve for x. That'll give us the 3x coordinates. So first of all, let's take this and plug it into the left side of this equation. So 3x minus 24 squared is equal to x cubed plus x squared minus 720x plus 5184. If we expand out the left side, we get 9x squared minus 144x plus 576 equals this right side. And then we can subtract so that we have a cubic polynomial equal to 0. So we'll subtract 9x squared from both sides. So x squared minus 9x squared is negative 8x squared. We can add 144x to both sides, which will give us a negative 576x. And we can subtract 576 from both sides, which will leave us with 4,608 right here. You should check behind me to make sure that I'm doing all my arithmetic correctly. And now, to find out the x coordinates of the points of intersection, I just need to factor this polynomial down. Now that can take a while, but we actually have a great big hint. We already know what 2 of the solutions are. We know that one solution is negative 24, and another solution is 8. So let's go ahead and use synthetic division to factor out an x plus 24 and an x minus 8. So let me make room for the synthetic division here. We know that negative 24 is one of the roots. Let me put the coefficients here. 1, negative 8, negative 576, and 4608. Let's go through the synthetic division. Bring down the 1. Negative 24 times 1 is negative 24. Negative 8 and negative 24 is negative 32. Negative 24 times negative 32 is 768. Negative 576 plus 768 is 192. And it seems like a miracle, but negative 24 times 192 is negative 4608. So we get a remainder of 0. Kind of seems like a miracle, but we knew it had to happen since negative 24 is already one of the x-coordinates of the points of intersection. Now let's do the same thing with 8. So continuing the synthetic division, I'll put the 8 in. So 1, 8, negative 24, and 8 times negative 24 is indeed negative 192. So once again I get a remainder of 0. So my third factor down here is going to be x minus 24. So in other words, this polynomial factors as x plus 24 from here, x minus 8 from here, and x minus 24 from down here, giving us the three solutions. X1 is negative 24, x2 is 8, and x3 is positive 24. And this is the one that we want. So for P star Q, the x-coordinate is 24. Now let's figure out what the y-coordinate is. I'm only going to erase up to here. In order to get the y-coordinate, I can either take this x3 and plug it into the complicated equation, or I can plug it into the equation for the line. The line is going to be much easier. So the y-coordinate of P star Q will be 3 times 24 minus 24, which is 48. And then last, we need to reflect across the x-axis, and that will give us the P plus Q. So to reflect across the x-axis, we just change the sign on y. So in this example, we have that P plus Q is equal to 24, comma, negative 48. Now, as a second example, let's see if we can find P plus P. So remember, in pictures, if I want to add a point to itself, I need to draw the tangent line to the graph at P. It's going to cross way down here. And then I reflect that across the x-axis. So this point down here is P star P, and the reflection up here is going to be P plus P. And remember, another name for that is 2 times P, 2P. So, since I'm working with a tangent line, I need to find the slope of the tangent line to the graph. And we know that that's given by the derivative. Let's use implicit differentiation to find the derivative of y at the point P. So let's differentiate using implicit differentiation. The derivative of the left side with respect to x is 2y dy dx. Differentiating the right side with respect to x, I get 3x squared plus 2x minus 720. So dy dx is equal to 3x squared plus 2x minus 720, all divided by 2y. So at the point P, the slope is going to be what I get when I plug negative 24 for x and negative 96 for y into this formula. So it'll be 3 times negative 24 squared plus 2 times negative 24 minus 720, all divided by 2 times negative 96. Simplifying the numerator, we get 960, and simplifying the denominator, we get negative 192. And that quotient is negative 5. So the slope of the tangent line at this point P is negative 5. Now let's use the point slope formula to figure out an equation for that tangent line. Using this point P and a slope of negative 5, we have y plus 96 equals the slope, negative 5, times x minus a negative 24. So times x plus 24. So y plus 96 is equal to negative 5x minus 120. So the equation for the tangent line is y equals negative 5x minus 216. Let me go ahead and write that next to the line. Y equals negative 5x minus 216. So I'm going to erase this, and we're going to figure out the points where this line crosses this cubic. So substituting negative 5x minus 216 for the y, we'll square that and set it equal to x cubed plus x squared minus 720x plus 5184. So watch it, the numbers are about to get kind of big. If I take negative 5x minus 216 and square it, I'm going to get 25x squared plus 2160x plus 46,656. Again, you should come behind me and verify that I've multiplied that out correctly. The right side I'll just bring down. X cubed plus x squared minus 720x plus 5184. And then like before, I'm going to subtract to get everything on the right side. So I have x cubed, x squared minus 25x squared is negative 24x squared. Negative 720x minus 2160x is going to be negative 2880x. And 5184 minus 46,656 is negative 41,472. So, oops, I already have it equal to 0 over here. So now we just need to find the 3 solutions to this. Again, good news is we already know what 2 of the solutions are. They're going to be negative 24 and negative 24 again. Let's verify that using synthetic division. So let's take negative 24 into 1, negative 24, negative 2880, and negative 41,472. Bring down the 1. Negative 24 times 1 is negative 24. Adding negative 48. Negative 24 times negative 48 is 1152. Adding, I get negative 1728. And negative 24 times negative 1728 is 41,472. So I get a remainder of 0, just like I ought to. But since this is a point of tangency, that point has multiplicity 2, so negative 24 is going to be a root of this polynomial as well. Let's do the synthetic division. Bring down the 1. Negative 24 times 1 is negative 24. Adding, I get negative 72. Negative 24 times negative 72 is 1728. So my third factor is going to be x minus 72. So my three solutions are going to be x1 is negative 24, x2 is negative 24, and x3, when I set this equal to 0, I get x3 equals 72. So the x-coordinate of p star p is positive 72. To get the y-coordinate of that point, I can take the 72 and substitute it into the equation for the line. So since y is negative 5x minus 216, if I substitute in 72 for x, I have that the y-coordinate will be negative 5 times 72 minus 216, which is negative 576. So that's the y-coordinate of p star p. And then to get p plus p, I reflect that above. So that changes the sign of y, giving me 72, comma, positive 576. So the conclusion is that when I double the point p, in other words, when I take p plus itself, I get 72, 576.